Okay, I think we're recording. We're going to do one quick AP question here from 1999, and this is on the calculator portion of the test. Yes, this is on the calculator portion of the test. I doubted myself there for a moment. And up at the top there, I think that these variables have kind of cut off a little bit. That's a t, and this is an r of t. I don't know that I made that any better. We're going to clear that and just start fresh. T and r of t. We're going to talk about some Riemann sums, which is what we talked about last week. Let's read it to start with. The rate at which water flows out of a pipe in gallons per hour, so units are going to become important, is given by a differentiable function r. So if a function is differentiable, think about what that means or implies. Hopefully you're thinking about being continuous. If something is continuous, it is differentiable. Now, why would water flowing out of a pipe need to be continuous? Well, it's just flowing out of the pipe. It's not going to start and stop every 10 seconds. It's just going to keep coming. The table above shows the rate is measured every 3 hours for a 24-hour period. So we've been given a table, which was something that we talked about last week as well. Part A, use a midpoint Riemann sum with 4 subdivisions of equal length to approximate the definite integral from 0 to 24. That word approximate in there says that it's okay for us to use a Riemann sum. Using correct units, explain the meaning of your answer in terms of water flow. So units are going to be important as we get going. So we talked about using Riemann sums last week, where we would just go from 0 to 3, 3 to 6, 6 to 9, and we would use every interval. But here they said to use 4 subdivisions. So how are we going to have to divide that out to get from 0 to 24? Well, let's see. What would happen if, because if I go from 0 to 3, 3 to 6, 6 to 9, we're going to have too many. We only want 4 of them. Well, 24 divided by 4 is 6. So if we went from 0 to 6, 6 to 12, 6 to 18, and 6 to 24, do we have 4 subdivisions? We certainly do. And hopefully we see that we have subdivisions of width 6. All right, then how can I go about approximating? What am I going to do? Which values am I going to make use of? Well, the hint is right there. It says use a midpoint sum. So we're going to use the midpoint. So what we're going to end up doing is finding those values, r of 3, r of 9, r of 12, r of 21. And we're going to end up using rectangles. We're going to have a height here of 10.4, but what's my width? My width is 6. So I'm going to have 6 times 10.4. Might be nice of us to write down 6 times r of 3 plus 6 times r of 9 plus 6 times r of 15, and finally 6 times r of 21. You might be looking at that and going, well, I could just factor out a 6 and take 10.4 plus 11.2 plus 11.3 plus 10.2, and you certainly can. So go ahead and number punch that. So this is going to be the definite integral of r of t dt from 0 to 24. We're going to add up all those values, and hopefully you get 258.6. But what's the label? Well, if I took hours up here times gallons per hour, I'm left with gallons. There's my label. There's my answer. Let's make sure that we've answered everything that we're supposed to. It says using correct units, which we've done. Explain the meaning of your answer. Well, what's that meaning? The meaning. Well, this is approximately how much water has come out of the pipe. So it's the total water flow. So this is approximately the total, oh my goodness, total flow in gallons. We like to make use of that label from the pipe in that 24-hour period. And hopefully your handwriting's nicer than mine. All right, hanging in there. Questions on that one? Jot things down if you do have some questions. Part B. Part B says, is there some time t between 0 and 24 such that r prime is 0? Well, and I would guess that some of you are thinking that, yeah, there is. Seems to be about a maximum somewhere around that t equal to 12 time. Yeah, it probably is about in there somewhere, but we don't know for sure. But we can say that, yeah, there is some place where r prime is 0. And this is the question that I said would come, but we just didn't know enough yet to talk about it. But this question really is referring to the mean value theorem. And if you remember about the mean value theorem said if we had a continuous closed differentiable function, which we do, so a continuous and differentiable function over a closed interval, that the instantaneous would be equal to the average at some point. And this is our instantaneous. We want to know, is there some place where the instantaneous rate is 0? And there is. Well, I want you to look at the values of r of 0 and the value of r of 24. What do you notice about those two things? Hopefully you're going, they're equal. Well, because they are equal, what is the average rate of change from 0 to 24? That average rate of change is, you guessed it, 0. So since r of 0 is equal to r of 24, MVT tells us that there is a time t in this interval where r prime is 0. That's a pretty good gig. All right, how we doing? Let's keep trucking here a little bit. And the last question. Uh-oh. I don't have a last question for some reason. Well, that's all right. Part C. I wonder. There we go. Part C. We don't necessarily actually know how to do this in terms of, it says something about the rate of water flow, and it says something about, there it is, that's what I was looking for, the average rate. We don't actually know how to do average rate yet. We know how to do average rate of change, which is f of b minus f of a all over b minus a. But average rate is actually a definite integral thing, which we're going to get to shortly. But I do want to do this problem more just for the sake of practicing your calculator keystrokes. So don't fret too much about understanding this one yet. But it was just an opportunity for us to practice our calculator keystrokes while we're snowed in today. So average value, average rate instead of average rate of change. This is just an average value problem. This is what we're going to get to. It says that we're going to find the definite integral. We're going to figure out how much area has accumulated, but on average, so over this average time. And so one thing that is part of this is that we're going to divide by 24, because our time period was 0 to 24. We're also going to go from 0 to 24. And then we're going to just use this Q function in here. and we're going to integrate that. And using your calculator, remember your keystrokes, remember where F and int was located, math to number 9, and then you're going to type in this function q, and I'm not going to retype it, we're just going to, okay? So type that in, comma, then you're going to type in an x and a 0 to 24. When it's all said and done and you get your answer, I guess that's when I would take your answer divided by 24 to get the final answer. And our label here will be gallons per hour. We've accumulated gallons and then divide by 24. This is 24 hours, so that's where the per hour comes into play. All right. Okay, so yeah, I think that's kind of all I need to say there. In terms of what you would need to have written down for the AP test, this first line, do not write your calculator keystrokes. That was just me helping you along. But that first line would suffice along with your answer there. All right, so practice those calculator keystrokes. Get back to me, let me know if you have some questions on that. So